Okay, this is a quick video about how to set up input and manifold pressure on a two-stage gas furnace. This is a Bryant 926 series two-stage gas furnace with a variable speed blower. And here's our gas line coming in. Of course, we have our shutoff. If we follow this gas line around, you'll see that we come to a regulator. That's because this system is a 2 psi system coming off the meter. Most new houses with a lot of gas appliances, especially with a tankless water heater, are going to require a 2-pound system to carry all that gas flow. So we're going to step down the pressure from this regulator, and that's going to feed this furnace. There's also a T here that will feed another appliance, but we're just going to concentrate on setting up the pressures on this furnace. Now, I love these Fieldpiece JL3MN pressure probes. I use them for static pressure, but you can also use them for setting up manifold pressure. So what I've already done is I've located the input pressure port and the manifold pressure port. Of course, the input is going to have live gas on it anytime this valve is on. The manifold is only going to show pressure when we're calling for heat. And since this is a two-stage furnace, our manifold pressure will be a lower pressure on low stage heat than it would be for high stage heat. Just a quick safety reminder, I have turned power off to this furnace. You never want to bleed gas with power onto the furnace, and definitely you don't want to do it when it's running. So let's go ahead and back off these plugs. Now you can remove them. If you have trouble reading consistent pressure, you may want to remove the plugs. I try not to because they're so hard or so easy to drop and lose. I just don't want to do that. What's nice about this Fieldpiece kit, it comes with these adapters. This is just 3/8 poly tubing, but it has a nice barb fitting that makes it really tight, and it just slips right over this connection. We'll do the same thing on the manifold pressure. Now, I don't know, this is a brand new house, so I don't know whether or not this gas line has got a bunch of air in it or not. So actually what I'm going to do is unhook this tube and turn on my gas, and I'm sure you can hear some gas coming out. And I'm just going to smell until I smell gas. So I've opened up my Fieldpiece app. And right now, the only tool that I have connected are my manometers. The red manometer is hooked up to my input, and the blue is my manifold. Now, if you notice here, I'm running 8.89, or essentially 8.9 inches water column of my input pressure. So what should it be? Well, for that information, we have to go to the nameplate of the furnace. So here we have the nameplate, have our model number, other relevant information, and I've circled some of the important stuff that we're going to want to pay attention to. So we were talking about what our max inlet gas pressure should be, and we found that here, and what we're looking for is 13.6 as a max. The minimum is 4.5. Well, we read 8.9, so that falls in between those two numbers. That's fine. Everything about these furnaces is about a range. We're not really dialing anything in anymore. There's a lot of forgiveness with these furnaces. The next thing we're going to look for is what is our manifold pressure. Well, here in North Carolina in Greensboro, we fall in this 0 to 4,500 feet. Our manifold pressure in inches of water column for high stage should be 3.2 to 3.8 inches of water column. For low stage, it should be 1.3 to 1.7. So we're going to first run this furnace in low stage heat. So this is what our manifold pressure should be, somewhere between 1.3 and 1.7. Let's see what we actually have. So our furnace is calling for W1 only. And we're going through a pre-purge cycle, which is the inducer draft motor running for a few seconds and moving any unwanted gases out. Now we go for a trial for ignition. Our glow coil glows hot. We'll soon hear the click of the gas valve, and we should have ignition. And we do have ignition. So what is our manifold pressure? Well, after we let it settle out, it looks like it's running about 1.9. Well, if you recall, our nameplate called for 1.3 to 1.7. So we're running a little bit high. So I'm going to back off this brass plug. So I've just taken off both of these brass plugs that cover our adjustment. And since we're running a little bit high manifold pressure on our low fire, we're going to turn this counterclockwise. Now there's a small regulator in here, and when we turn it counterclockwise, we're going to be reducing the amount of spring tension that is pushing to open that valve. And as we do so, if you notice my P1, my blue number is starting to come down. Again, our range is somewhere between 1.3 and 1.7, so we'll put it right here at 1.5. Now, if you notice, this is a range. We don't have to dial these things in exactly. There's a lot of forgiveness here. What counts is it burning cleanly? Are we heating properly? Do we have a proper rise, temperature rise? Is it too high or is it too low? Are we protecting our heat exchanger? Those are the important things. The actual number, as long as it falls somewhere in that range and we're protecting our furnace, protecting our homeowner, it's really negligible. I know I'm going against a lot of smart people in the industry by saying that, but I have not been able to get a straight answer from them yet about why we need to clock gas meters and do things like that with modern furnaces. I just don't see why. And we're going to check our manifold pressure again. Now, if you notice, we are at 3.72. What was our range? It was saying that it wants to see between 3.3 and 3.8. So we're within that range. We can maybe adjust it just a little bit. So maybe I'll do that just to show you technicians what happens when we start backing off on this screw. Now, if you notice, even the tone of the gas burning has changed. You can hear it getting quieter and quieter as we adjust this. And there's quite a bit of adjustability. As you can see, I'm turning this all the way down around 2.0, 1.8. This is really one of the only two adjustments you can make to a furnace. You can make manifold pressure adjustments and airflow adjustments. That's it. So I'm going to leave the manifold pressure right now at 3.4. Well, we need to check what our temperature rise is across the furnace, and we're going to do that next. So what should be the proper temperature rise on this furnace? Well, we've got a few things to go by. Right here on our high fire, it's saying it wants to see somewhere between 40 and 70 degrees Fahrenheit rise. We also do not want to exceed 165. So as we can see here, we're running a very high return air coming in. That's because this house is hot and it's hot outside. But our rise is still 45 degrees. So really, no matter what the return air temperature is going to be, this furnace is going to have a 45 degree rise in high fire, which is well within our specs from the manufacturer, so we're happy with that. Now, even with 85 degree air coming into this furnace, we're still only producing 131 degree supply air, so we're nowhere near that 165 degree max air temperature. So during normal conditions, when it's 70 degrees in the house, we can expect this temperature to be even lower, and everything's within spec. I'm very happy with how this is turning out. So finally, it's time to button up the furnace. Well, the very first thing we're going to do is take away the call for heat. That's going to allow this furnace to cycle off the proper way. You don't want to be right in the middle of a high fire cycle and just kill power to it, because all that heat is going to be in the heat exchanger, and you can really do some damage to the heat exchanger over a period of time doing that. Now, the proper way to shut down this furnace is to kill the call for W. You make the flame shut off. 30 to 90 seconds later, your blower will shut off, but by that time your heat exchanger is cooled off, and finally it's ready to kill power. The other thing that you want to do is make sure that you turn gas off before you start pulling your probes off. So I've killed my gas supply. I'm going to pull off my input pressure, and this is the most important part of the job. We have to tighten up these needle plugs and snug them. Now, you don't have to crank down on them, but you do need to snug them, excuse me. We'll do the same thing on the manifold pressure side. Finally, we're going to put our brass plug covers over our adjustment screws back on, and we'll snug them with a flathead screwdriver. The last thing to do is just make sure everything is back to where it should. Make sure there's no wires that could be rubbing on an inducer motor. Make sure this unit is ready to be buttoned up, which it is. The second most important part of the job is to make sure that you turn everything back on when you're done, or else you're going to create a callback. You're not going to be happy, the customer's not going to be happy, and most importantly, your boss man, which is me and my company, will not be happy. And then wait around and make sure the unit comes back on. Now in this case, our unit's going to come back on in cooling mode, but we're going to wait a few minutes and make sure everything's good before we walk away.